right, so for these three problems, we're going to refer to this setting. A psychologist studied the number of puzzles that subjects were able to solve in a 5-minute period while listening to soothing music. Interesting. Let X be the number of puzzles completed successfully by a randomly chosen subject. The psychologist found that X had the following probability distribution. I wonder what the song was. All right, so you have X values of 1, 2, 3, 4, probability of 0.2, 0.4, 0.3, 0.1. So what is the probability that a randomly chosen subject completes more than the expected number of puzzles in the 5-minute period while listening to soothing music? So part of this is making sure you can understand what the problem is, asking for. So it's saying probability that if they complete more than the expected number of puzzles. So we need to find the expected number of puzzles. We need to find, E of X, also known as the mean of X. And this is given in your formula sheets. So make sure you get comfortable with this. So you do get a formula packet on your AP exam, and I'm sure your professors or teachers will let you use one, but make sure you know the notation. So for this, we got a random variable, discrete random variable in this case. It takes on, whole numbers. And the mean, or expected value of X is given by the sum of the corresponding X values times their matching probabilities added together. So what that means is that you're going to take 1 times 0.2 plus 2 times 0.4 plus, I'm just going to go to the next one, I hate squeezing it, plus 3 times 0.3 plus 4 times 0.1. And you should get 2.3. The expected number of puzzles that will be completed in this 5-minute period is 2.3. So we want to find the probability that a randomly chosen subject will complete more than 2.3 puzzles. So the probability that X is greater than 2.3 is what we want to find. Now, since this is a discrete random variable, we're only looking for the probability of 3 and the probability of 4 added together. So this is going to be equal to the probability that X equals 3 plus the probability that X is 4, because both those are larger than 2.3. And that would just be 0.3 plus 0.1 would be 0.4. So the answer is B. All right, problem 2. The standard deviation of X is 0.9. Which of the following is the best interpretation of this value? All right, so this one, pay attention to the wording carefully. Remember, standard deviation in general, the general way you want to interpret it is the average distance that a randomly selected, individual will be from the mean, how far they'll be from the mean on average. So on average, the value of, randomly selected, X will be about 0.9 away from the mean value of 2.3. So it's not about 9, it's not going to be A. We're not talking about percentages here, not 90%, plus 60%. So C, a typical subject solved an average of 0.9. So that's the interpretation of, that's kind of the interpretation of mean. Not exactly, but that would be going towards the interpretation of the mean or expected value. All right, D, you can see the number of puzzles solved by subjects typically differed from the mean by about 0.9. So that's what we're looking at. On what's the average difference from the mean value? That's how we want to interpret standard deviation. So the answer would be B. Remember, standard deviation, spread, how far is it away from something else? And let's, for problem 3, let D be the difference in the number of puzzles solved by 2 randomly selected subjects in a 5-minute period. What is the standard deviation of D? So if D is the difference in the number of puzzles solved by 2 randomly selected subjects, let's have the subjects, be like X1 and X2. So D will be x1 minus x2, we'll say. So, so we want to find the standard deviation of D. Now the mean of D, let's mention do it anyways. The mean of D will just be the mean of x1 minus the mean of x2, which will be 0 because both of them, we're talking about the same, distribution that they're being selected from. They both have a mean of 2.3, so this would just be 0. But we want the standard deviation. We want to find the standard deviation of D. Now, we can't get the standard deviation straight up by just, adding, subtracting, or multiplying, but we can find the variance. So what we're gonna do is find the variance of D and then take the square root, because remember the standard deviation is the square root of the variance. Now, variances can simply be found by adding the variances of whatever make up a variable. So if you have another variable that's made up by the sum of two variables or made up by the difference of two variables, in this case, we get D is a difference of x1 and x2. Even though they're being subtracted, the variance of D is still going to be the variance of x1 plus the variance of x2. Yeah, and it's kind of counterintuitive. It's kind of, sounds like it doesn't make sense. But I kind of explain it in another video, but for now, you just gotta accept this. So as you're studying for a test and it's a problem like this, when you're trying to find the difference, the difference, say you have a random variable that's made up by subtracting two random variables, the standard deviations are going to add no matter what. I mean, the standard variances are going to add whether or not the variable is being subtracted or added by two other variables. So then here we take the standard deviation of x, which is told to us that it is 0.9. So we're gonna have 0.9 squared plus 0.9 squared. So you know 0.81 times 2. So 1.62. And so the standard deviation of D is the square root of 1.62, which would be about 1.27. Our answer is D again. All right, and problem 4, so we're talking about a different scenario now. Suppose that we have a student that's randomly selected from your school. Which of the following pairs of random variables are most likely independent? Okay, so this just use your common sense understanding of the real world. So what variables are most likely to be independent? A student's height versus their weight. Now, for the most part, it's not like a strict formula. You can't necessarily figure out someone's height from just their weight and vice versa. But we can say there is we kind of know that there is a relationship. The taller you are, the more you weigh, in general, and vice versa. So probably not that. A student's IQ and their GPA. Again, GPA is also, made up by, how hard working the student is. But we all know there are some students that are just naturally smarter and gifted in certain subjects. So it's easier for them to get the higher grades. So not that. The student's SAT math score, the student's PSAT verbal score. Now, even though, there's a big common, saying like, oh, English and math are, the opposite subjects. You can be good at English, but not good at math. But in general, when you're in school, when you're studying and you're a good student, you can do well on both or bad. But there is a relationship. The better you score in math, the better you're usually going to score on English, because you're probably a more studious student. So probably not that. D, the average amount of homework the student does per night and their GPA. These definitely should be related. The harder and more homework you tend to do, the higher your GPA is. Not that one, so it's probably going to be E. So the average amount of homework that a student does and their height. Yeah, your homework is not going to, really be related to your height. These are most likely to be the ones to be independent out of all of them. these 5 scenarios, so our answer is going to be